Hi, I am danmirceasuciu. Welcome to Software Project Management Course Notes, a podcast created based on Agile Software Development online classes I deliver to Software Engineering Master Program at the Faculty of Mathematics and Computer Science from Babeș-Bolyai University. A framework which was defined by project manager. His name is Dave Snowden. Dave Snowden was a project manager at IBM, so he used to coordinate a lot of projects in IBM, big and small projects, distributed and collocated projects, and based on his experience, he defined this framework. He called it Cynefin framework. Dave Snowden is from Wales, and this Cynefin word is a Welsh word. If I'm not wrong, it means home. And he defined this framework to give us an idea about how to approach different challenges or different situations or different problems we meet during our professional and personal life. So it is very useful in many contexts. Of course, that he doesn't give us solutions. He only gives us some hints about how to approach a specific problem. So this Cynefin framework is a decision-making framework. And he started by identifying three different systems, because he said that around us we have many things, many objects or other systems which are part of these three categories. So we have ordered systems, we have complex systems, and chaotic systems. And which is the difference between these systems? Which is the difference between ordered and complex and chaotic systems? What are the main properties, the main characteristics of each system? And for this, Dave Snowden used the connection between cause and effect. So this connection between cause and effect, this connection between one action, let's say an action A, which causes an event B, is very important for us. And this is also the way Dave Snowden used to define what an ordered system is, what a complex system is, and what a chaotic system is. For instance, he said that in an ordered system, there is a very clear connection between cause and effect. All the things are ordered and logically linked together there, and for us is it is very easy to understand what will happen if we will do one action or another. In an ordered system, besides the fact that this link between cause and effect exists, it is repeatable. Every time when we do the same thing, it will happen, it will generate the same effect. Again and again and again. This is one very important characteristic of order system. And more than that, it is not necessary to do that action. We can anticipate what will happen. We just have to analyze that ordered system, and we can predict if we will do action A, the event B will happen. The things are so clear that we can do this prediction. So it is an order system is actually a predictable system. It is very clear what happens when we interact with that system, which is pretty different than complex systems. Here again, there is a connection between cause and effect, but that system is so complex that it is almost impossible to anticipate this connection, to anticipate this link. Maybe you know that saying, which says that a butterfly flying somewhere in South America can generate a big storm in Japan. Maybe yes, maybe no. We don't know exactly, and it is very, very complicated to connect these two different events. Maybe there is a logical link between them, maybe not. It's hard to say if this really happens. So when we talk about a complex system, we talk about a system where there are a lot of components, a lot of links between those components. There is a certain level of uncertainty, certain level of uncertainty. So there are a lot of things which are still unknown for us. There is a certain level of ambiguity and volatility, and that makes that system complex. So in this case, even if we have a connection between cause and effect, this is not predictable. And more than that, it is not written here, but more than that, it is not repeatable. In a complex system, if I do one action A, it could generate an event B, an effect B. But the second time when we do the same thing, maybe we'll have another effect. I don't know, B2 or C or something completely different because of the complexity of that system. And how we can reproduce that connection between cause and effect, analyzing the effect. So we analyze the effect and we go backwards in retrospect. We said, oh, this happens because of this and this and this, and finally we do the link with what we did with the initial action. And in this way, we discover the connection between cause and effect. In order system, we discover it directly from cause to the effect. Here, we have to analyze the effect and after that to reproduce the link. Let me give you an example here. For instance, human communication is a complex system. I'm the one who sends a lot of messages to you, but there are the same messages with the same words. I'm using the same slides with the same gestures and tone and everything else. But I must be, I have to be very honest with you. I don't have any clue about what you understand from my messages. And it is very possible that you will understand different things because you are so different and I don't have any idea about these differences. I don't know a lot of things about you. I don't know anything about your culture, about your education. I don't know about your mood. Any of these are some noises that could affect your understanding of my messages. So you can understand different things from the same messages I'm sending to you because it is a complex system. It is a lot of uncertainty, a lot of things I don't know about. Maybe let's say if we talk together and you will tell me, look, I understood this, and I will try to analyze, and maybe I will ask also a couple of questions, and I will see, I will say, you understood this because of that and that and that and that, and I will do the link with my message and with my words and with my sentences. But I'm able to do this connection only after that, only in retrospection, only backwards, going from your understanding to my message. Right now, I don't know exactly what you understand. I don't know if you even pay attention to this course, most of you. And this is another thing. So in a complex system, again, there are a lot of items that compose a complex system. There are a lot of links between those components. there is a certain level of uncertainty, of volatility, of ambiguity, and that makes a complex system a little bit unpredictable. So it's very difficult to anticipate something here. Okay, now it is even worse when we talk about chaotic systems, because here there is no link between cause and effect. We do something, another thing completely random happens without any visible connection, without any logical explanation. This is how a chaotic system behaves. And there are many chaotic systems around us. Now, starting from these systems, Dave Snowden defined 4 categories of problems. So he split ordered systems in 2, and he identified obvious problems or situations, complicated problems, complex problems, and chaotic problems. And what he said, what Snowden said, that for each of these categories of problems, there is a certain way to approach that problem, to find a solution for that problem, which is the most effective. Of course, that you can find a solution for a problem in many ways, in different ways. But there is one way to approach it to minimize the effort, to minimize the time you spend in finding the solution, to minimize the costs, and to minimize the resources you involve in solving that problem. And this is how this framework, Cynefin framework, helps us. And let me start with the obvious problems, with the most simple problems, and we will go to complicated, complex, and chaotic. Okay, so now the way to approach obvious problems is this one. We have to sense the problem, to categorize it, and based on the category it belongs, we have to respond to it, to solve it. Because in that category, we have a best practice, or we have a process, or we have an algorithm we can use in order to solve that problem. This happens with obvious problems. They are very, very, not necessarily very simple, but very clear. And here the connection between cause and effect, as we already talked about, exists. It is repeatable and it is predictable. More than that, this connection between cause and effect is obvious for anybody. You don't have to be an expert or a specialist in a specific domain in order to understand these problems and to solve these problems. It is not necessary. You can find a recipe or an algorithm or a process on the internet, on YouTube, and just to follow the steps of those processes, you are able to solve that problem. This is very, very clear. So one very simple example of an obvious problem is to change the password of your email account or of the social network account. Anybody knows how to change the password of his or her account. And if that person doesn't know how, based on the messages that person receives, is able to understand what has to do in order to succeed changing that password. It's very simple. Or just after a very simple search on the internet, you can find the steps you have to follow in order to change your password. Another example. Let's suppose that I'm staying alone in my room on my computer, and suddenly there is no internet connection on my computer. I'm trying to solve this problem, to do a lot of things, but I don't succeed to find a solution. Now, usually what we do next is to call to the customer support of the provider, of the internet provider. It is the first level of customer support. Now, when we call at the customer support, the other person who answered that call is not a specialist. Is not a person who is an expert in networking, in internet, or in, I don't know, in stuff like this. It is a person who has, I don't know, a piece or many pieces of paper in front of her, and on those papers are some steps. Maybe the first step is to check the power, the electrical power, and the modem. The other step is to check the electrical power if your laptop has power. The other step is to reboot your computer. The other step is to look settings, systems, and to see what is there and to do some changes there and so on, step by step, step by step. And she will start with the first step, and she will ask me, please check your modem. Does it have power? And so, even if I say, well, look, I did already this, and I didn't solve the problem. That person who answered the call will not let me to skip some steps. She will say, no, 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 please do what I ask you, and let me know the result. Why? Because most of the people actually is based on the statistics is 80% of the people. 80% of the people who call at customer support, they have obvious problems, and their problems will be solved after going through all these steps. It is enough to go through all these steps to solve their problems, because they have usually obvious problems with internet connection. If I have bad luck and I'm not part of those 80%, that 80% of people, the answer will be, the final answer will be, well, I cannot help you. I'm sorry, sir, I cannot help you, but I will send you somebody. Well, that somebody is an expert, because my problem is not an obvious problem. It is a complicated problem. It needs an expert. It cannot be solved just following this process, just following these steps. It is not enough. Okay, so just to conclude, here, for obvious problems, we have best practices. Actually, it's best practice because if it's the best practice, it is only one, isn't it? Usually we have in a lot of, in our organizations, in our companies, a lot of processes which are defined, processes which are repeatable, and we can use them continuously every time when we meet such an obvious problem. Following those processes will give us the best solution again and again and again for that kind of problems. Yeah. So it's a sequence of actions we have to follow in order to perfectly solve the problem. Now, it is a little bit different when we talk about complicated problems. Because, yeah, okay, also complicated problems are part of the order systems. So here we have a connection between cause and effect, which is repeatable, and it is predictable. But it is not predictable by anybody. You have to be an expert. You have to be a specialist in a certain field in order to see this connection and to anticipate that if we will do this, we will succeed in solving our problem. So here we need experts for complicated problems. And the steps we have to follow are these three. We have to sense the problem, to analyze it, to analyze the problem. This analysis phase is very important. So it is not possible just to categorize it immediately. We have to analyze it, and only after that we will respond with a scenario. We have to do this in order to solve a problem. This is the way, and this response is given by an expert again. So let me give you an example also here. So let's suppose that I enter into my car and I try to start the engine, and the engine doesn't start. And I try again, and no effect. Nothing happens. So as you can imagine, I'm not an expert in car engines. I don't have any clue how they how I can repair or to solve a problem like this. Uh, my first thought, anyway, my first thought, and this happens very often, is to think that maybe this is not a complicated problem. Maybe it is an obvious problem. So, first of all, I will check the fuel, and I will see, okay, I have enough fuel, so it's not a fuel problem. And after that, I will check the electrical power, the status of the battery. Is it okay? And if it is okay, that's all. That's all I can do. I don't know how what exactly to do in order to finally start the car engine. So I have to call somebody, an expert. And that expert will come. He has to analyze the situation. So it's not enough to look at my car and tell me the solution. He has to analyze that situation. And that after a couple of minutes or maybe a couple of hours, maybe it's a really very complicated problem, he will turn around. He will show me, look at this component. This is broken. You have to buy another one. I will install it into your car, and your engine will start. Will function well. Okay, but what happens is that if I call somebody else, it is very possible that that person will come with another scenario, with a different solution. Because this happens when we talk about complicated problems. We don't have a best practice. We most of the time have many good practices, many good ways to solve the same problem. And maybe that person will do that analysis. He has to do to analyze the engine, and he'll turn around and he will say, look at this component, this is broken. I can repair it. I can fix it. And after that, I will install it back, and your engine will start. Or another one could say, again, after an analysis phase, look, this component is broken. I know a workaround. I know a way to start the engine without using this component. And you can use your card in this way. Now, I cannot say that one solution is good and the other one is bad. Uh, all these scenarios are good because all these three scenarios will solve my problem. Now, I have to decide which scenario is good for me, and this is done based on the limitations, based on the restrictions I have. I have to ask myself how much money I want to spend on these repairings, or how much time do I have to wait till the car is okay. Or another question could be about the quality of the result. I will meet in the future, in the near future, the same problem again. Maybe in the third case, the answer is yes. But the third scenario is faster. So if I'm in rush, maybe the third scenario is best for me at that moment. If I want to have something which is durable, so which will last in time, maybe I will go for the first scenario. But in that case, I will spend more money for the repairings. So there are a lot of things here I have to think about in order to decide which scenario I will choose. So in conclusion, here we don't have best practice. We have good practices, is the plural, because we have many good practices. Each of these good practices come from experts in a specific domain who have to analyze first the problem in order to give me these good practices. And a very good example of a complicated problem is a traditional project, a classical project, let's say. A project where we have all the specifications which are stated very clear. It's a complete set of specifications. The objective, the scope of that project is very clear. What I need as a project manager is a bunch of experts able to build the product to build that service, the result of that project. They have to analyze in the beginning. So we'll have an analysis and planning phase in the beginning of that project. We have to identify the tasks. We have to identify the dependencies between those tasks. We have to do some estimates. We have to build an execution plan. And after that, we'll start the execution based on this plan. Maybe there will be many different scenarios coming from those experts, many different solutions to build that product. My responsibility as a project manager is to choose the right scenario based on the budget, based on the deadlines, based on the scope I have specified for my project. So these are the limitations, let's say. These are the boundaries. And based on them, I have to decide which is the best scenario, which is the best solution for this project. And we will start the execution. After that is the validation or testing phase. After that, the transition phase, when the product is ready, is finished, and we do the transition to the final customer, to the final client. Okay, and the last one, the last stage, the last phase is closing the project. Lessons learned, a lot of other things. You know them very, very well. You know them very, very well. And this is called a predictable way of project management. All predictable project management methodologies are here and are very useful for complicated projects like Prince2 or PMP, or they are generically called waterfall methodologies, because we have a lot of phases, and when we finish one phase, we do the transition to the next one without going back to the previous phase. Or this is in theory. In practice, sometimes we have to go back. Maybe during the validation or testing phase, we realize that something was done wrong during the development, or maybe some was not designed well in the designing phase, or even worse, maybe some important specifications we missed in the specifications document, and we have to go back. But anytime when we go back to a previous stage, it involves a lot of money, which will affect the budget, a lot of time, which will affect the deadlines, a lot of effort, which will affect my team members, and so on. Maybe also the quality of the final product will be affected about that. And because of this, I will try during that planning phase also to identify the risks and to find some to build a contingency plan, because I don't want that those risks to affect my my project. And somehow myself, together with all the other colleagues, with all the other team members, we can do this. Why? Because it is predictable. If we have enough time to analyze everything, all the specifications, we are able to predict, to do some good predictions about when we are able to finish the project, which are the main risks, how we can deal with that project, and so on. So the waterfall methodology is very good for this kind of project. But they are not recommended to be used in complex projects. And in complex projects, we have different situations. Thanks for listening to Software Project Management Course Notes. If you enjoyed this episode and you'd like to help support the podcast, please share it with others, post about it on social media, or leave a rating or a review.